Hi everyone, Jess here, and today I'm joined with Greg Ombach from Airbus, who will be joining us at ATW Europe in April. Thank you so much for joining me today.
Hi, Jess, and really welcome everybody. It's my pleasure being with you here today, and I hope we are going to have an interesting discussion.
I hope so too. So I thought we could have a little conversation around sustainability, tech, and innovation. And with this in mind, my first question to you would be, what do you foresee being the most disruptive technologies when it comes to sustainability? And is it going to be a matter of these entirely reshaping the industry?
Look, I'm really privileged because I'm working here with Airbus, and my title is Head of Disruptive Research and Technology. Therefore, if you talk about disruptive, you are in exactly right place. But it's not just about being disruptive, it's also about being incremental as well. It means a combination and balance between incremental and going to be disruptive. Now, if we just think about the sustainability, then we already said that by 2050, we have to reach as an industry net zero. It means this industry has to transform during the next 30 years. And being a privilege and working in different industries, like telecom business, where the lifetime of the product was about, or development of the product was about 1-2 years, then automotive about 7 to 10 years, the aerospace is completely different ballpark. Because in aerospace, we are talking about something like 30-50 years from the time when you start developing aircraft till the end of life of the aircraft. Therefore, it's much more longer. Therefore, everything what we do during the next 20 years, before we are reaching net zero, it's going to stay with us for the next years to come. Therefore, we have to make the right decisions. And knowing that during the next 20 years, the number of the aircrafts are going to double compared to this what we have today. It means today are flying about, I would say, 22,000 aircrafts, the big ones. Now, if we go to, in 20 years from now, based on the global market forecast, is expected that this is going to be double, about 46,000 aircrafts is going to be flying. Therefore, only from this aspect, we are going to have even more challenges on the CO2s, like sustainability, on the congestion, and of course, safety is the most important thing, which we always have to take into account. Therefore, a lot of changes have to happen during this time.
Absolutely. So it's no small challenge ahead of us, especially as you say with the scale up. If you had to pinpoint a couple of these disruptive technologies, what would you cherry pick?
If I will look this journey during the next 20-30 years, the few things have to happen in parallel in order to reach this target of net zero by 2050. First of all, we have to work on the exchanging the old aircrafts with the technologies which we have already today, because just by doing it, we can already reduce the emissions of about 25%, which is huge number. Now, if we would be able to optimize the operations of these aircrafts and optimize infrastructure, it means how long the aircrafts are going to be during the taxi process, or because of congestion, they are waiting and doing the loops around the airports and so on. This would bring us about the next 7% reduction. Of course, the biggest chunk is coming from using so-known sustainable aviation fuel, which is going to be more than 50%, and we are targeting having by end of this decade that all our aircrafts are going to be 100% certified for using sustainable aviation fuel. But also very important part is coming from this disruptive, and disruptive mostly is all about hydrogen. It means we communicated and we are working hard to bring into the life a hydrogen aircraft by 2035. And I will touch on this later because it's so exciting. And of course, we are working on improving even the safety, and it means more automation on the aircrafts, which are going to reduce load on the pilots. And then with this, automatically, you are improving the safety. And of course, we are also working on improving the technologies, like, for example, putting the longer wings with the high ratio, which are going to improve efficiency of the aircraft, where we hope getting about 10% out of this area. Now, just on this, we call it extra performance wing. You cannot just take the existing wings and put the longer ones, because then automatically when the aircraft is landing at the airport, you will have no chance to get to the gateway. Therefore, what you have to do, we have to do the foldable tips of the wing in order to be able to address this challenge. At the same time, the much higher wing during the flight, if the goose is coming, you have to control it. You have to put more sensors on board. And then with the newest technology and in the future AI, more AI-driven stuff, it's going to recognize such kind of a goose, and then you are going to be controlling this end of the tips in order to optimize performance of the aircraft itself. Therefore, a lot of the incremental things which are happening, more, I would say, between incremental and disruptive, like sustainable aviation fuel, but also a lot about disruptive technologies like having hydrogen aircraft or extra performance wings or similar.
Fantastic, thank you. And that leads on well to a project that you recently hit a really exciting milestone with towards the end of last year. So would you be able to tell me a little bit about how you're using innovative technologies and concept to make progress with your Zero E project, and perhaps just touch on the wider significance of the successful test that you ran towards the end of last year?
Yeah, this is really great, because Airbus' purpose as a leader in this industry is that we pioneer sustainable aerospace for safe and united world. And there is this pioneer sustainable aerospace. And this, in order to really have the zero emission aircraft, you can do it only, or you are going to have it pure electric, or you are going to have a hydrogen. And we are working on electric stuff, like, for example, eVTOLs, the kind of the helicopters which are electric vertical takeoff and landing vehicles. But they are short range because of the problem with the energy density from the batteries. Therefore, if you would like to do the aircraft zero emission, then the only way to do it is it has to be powered by hydrogen today. Because we cannot, that's only the energy source which still, in comparison to the kerosene which we are using today, has some disadvantages, but still it is only the option where you are not going to be polluting at all. Therefore, Zero E 2035, as was announced, we are going to bring this aircraft to the service. But before this is happening, a lot of the new developments have to happen. I will just give you a couple of the examples. And fortunately, I'm today in Munich, where we have so-known system house, where we are testing all the fuel cells with the powertrain exactly for this aircraft. And we just recently had a chance to reach with our fuel cell, which we put together with hydrogen, with power electronics, with electric motors working together on the common shaft. We reach more than 1 megawatt power, which is exactly the ballpark where we would like to go from one single unit. And this is going to be, this still has to increase, but now we are talking about the incremental improvement from this 1 megawatt. It's not anymore so disruptive as we have to do till now. Now, this is just a part of the journey, because we still don't know if we are going to be using the fuel cell with hydrogen in order to generate electric power, and this is going to be driving electric motors as propellers, or we are going to use hydrogen and we are going to burn it and then use the propulsion coming from this process. This is a parallel path, and we are focusing on both. And of course, in case of burning, we are working with our partners which have much more experience about the combustion engines as we have. In case of electric, it is what we do in-house, because we are developing the own fuel cells with the JV which we have with the automotive. It's Eli Klinger with Airbus, started a couple of years ago, and we call it Aerostech, where we're developing really the fuel cell system from automotive to aerospace, which the power density has to be much higher, and of course there are different operation conditions as well. Therefore, this is the main direction if we think about the fuel cell or burn or it's going to be pure electric. Now, the next thing which is challenging is all about cooling the stuff in the air, because you don't want to put anything around the aircraft, because then you are going to lose the performance during the flight. Therefore, you have to optimize efficiency of all systems in order to increase efficiency of the entire aircraft. And here we are working, and we tested as well. We call it the Ascent project. Now we are moving to the next level, and it's all about superconductivity. It means once we have already liquid hydrogen on board, because we cannot use gaseous, because gaseous is going to have a less energy density compared to the liquid. Therefore, we're putting the liquid hydrogen to our tanks in the future on the aircraft. And this liquid hydrogen has a temperature is 0 Kelvin. It means about minus 273 degrees C, therefore very cold. And before we put it to the fuel cell, we have to warm it to the room temperature. And therefore, we can use this low temperature to cool down all other systems on the aircraft. Like going from the fuel cell, you have all cables, you have then power electronics, you have electric motors, and with this you can increase efficiency of all of this equipment. Therefore, this is also the technology brick which we are working on from disruptive perspective, because this would give us later on higher efficiency of the entire system, and then of course reduce amount of the hydrogen we would need on board, therefore a lighter aircraft at the end of the day. And these are the, I would say, opportunities we see. And now is everything rolling out in the direction to prepare these different technology bricks from hydrogen perspective, but not forgetting this, for example, extra performance wing, where we have to still work on this, because this technology is still applicable independently what kind of the propulsion system you are going to be using. Therefore, this is very important. And at the same time as well, working still on the automation or smart automation, because the future aircrafts have to provide this support to the pilots, and then it's going to help us with improving the safety. And then hopefully in the future, once we have everything digitalized, we are going to have even this systems which are controlling aircraft are going to be more and more digital. Then with this, we'll be able to optimize the performance of the entire aircraft at the end of the day, even better compared to this where we are today.
That's great. Thank you so much for elaborating more on that. It's such an interesting development in the industry. And like you said, hydrogen carries this huge potential for decarbonising the industry, but it's this sort of double-edged sword, because it brings with it a fair few challenges infrastructure-wise.
Oh, yeah. Therefore, we are not just working on the aircraft. We are also collaborating with different airports to already learn in very early stages what does it really mean to bring the hydrogen there. And then if you just go the next step, you're going to ask, okay, where hydrogen is coming? Because we are talking about the green hydrogen. And here we are talking about the places where renewable energy like wind and solar has to be in place in order to generate the green hydrogen. And then you have to transport it to the airports, to the proper airports, and then you have to, of course, bring it to the aircraft in the proper way. At the same time, the other industries, like, for example, automotive, and especially the truck business, is also working on the hydrogen, because if we think about the long-haul trucks, then power them by batteries, very difficult. You could do it, but probably using the hydrogen as is done today as a gaseous, and maybe in the future liquid is even better option. Therefore, the different industries are working with hydrogen. If you think about sustainable steel, where the hydrogen is used as a mean of the energy as well, then there are also the opportunities here in the collaboration, not just inside the aerospace industry, but across different industries as well.
Absolutely. And thinking back to the sort of earliest days of these new ideas, you've spoken before about the role of your blue sky thinkers. What are the key challenges you encounter when translating their ideas into these pilots?
Just if I think about, the blue sky thinkers are the guys which are sitting in the central research and technology part of organization. And this is, I would say, probably only one place where you have to have people which are allowed to think not just 10, 20 years, but even beyond this period. And there are a couple of interesting projects which we are working there on. And one of them is the space-based solar power, which is also addressing, because at the end of the day, the future is about energy. It means where energy is going to be coming from. And then if you have energy, you could transform it to the different means, like hydrogen, for example. And the space-based solar power system is you are putting the solar powers in the space on the geo satellite and the geo orbit, honestly speaking. And then you are beaming electric energy as a microwaves to the Earth. You have the antennas here which are picking it up. And then once you have electric energy, which is 24/7, because on the geo you have a permanent sunshine, there is no day or night. You are beaming it to the Earth. Of course, all safety measures have to be taken into account for this one. Then you can use this, for example, to do electrolysis and make the hydrogen out of this, which we can power our aircraft in the future. Or, for example, you are going to be using it with you are capturing also CO2 from the air on the Earth with the direct air capture system, which we also developing in this parameter. And then you can combine the captured CO2 and hydrogen, and then it's going to be the sustainable aviation fuel, which is then synthetic, not bio-based, but synthetic-based. Therefore, at the end of the day, it's all about energy. It is why we are looking in that direction, like the solar-based systems. And another one is where we are looking at in that parameter is what about, for example, metaverse. It means once we have more digitalized everything, and we are talking about the LEO satellites, permanent 5G connectivity, high bandwidth, we talk about more computer power, which requires energy as well, then there will be more and more these metaverse aspects coming to us, where we will be able to use it or during development or during the daily work like we do today, or of course, once you are on board on the aircraft or similar. Therefore, the question is how this part is going to shake the industry as well. And we have to have a couple of the scenarios already today, what the technology brings to us. And another important aspect is what we do there is, for example, about the quantum. Because the quantum, we can talk about a couple of the different aspects. One, quantum communication, which we are using already today in order to have a secure communication, even more secure than we use till now. Now, then another one is about the quantum compute and algorithms, which are very important because this kind of the technology can help us with all kind of the simulations we are doing to design aircraft. Like, for example, CFX simulations about the flow around the aircraft. And then the next one is about the quantum sensing. And the quantum sensing is very interesting because if we think about more and more automation on board on the aircraft, then today we are using, for example, we're developing the system which is visual based, but we are also developing the technology which is, of course, using also GPS signals, but it's still not enough. You still need some redundancy, and redundancy in this case could be, for example, sensors based on the quantum, which are helping you to localize the aircraft in case if there's no GPS signal, for example. And in order to find out the good solutions, we just recently started together with BMW. We call it Quantum Mobility Quest. It's kind of the challenge, also supported by AWS, and we just started it a few weeks ago, which is going to be in 2024. And from the guys which are running from the Jasper, who is responsible for this in this part of our organization, I was already hearing that we have a lot of the interest coming for this challenge. And here, exactly these areas which I mentioned, we are trying to address and get feedback from the global ecosystem, startups, scale-ups, and so on, what kind of the potential solutions we can have with the future quantum. We still don't have answers, but we are on the way to find the best use cases which we specified, and then best solutions for those use cases. And the one of them, for example, which is important for aerospace, is the corrosion, because those aircrafts are so long in the service, then there's an issue with the corrosion, of course, and we have to address it. And then maybe quantum is going to help us to do better calculation of the corrosion effects. And then with this, we'll be able to optimize our aircrafts much better. Therefore, a lot of the things, positive things are happening. And now how this is finding the way into the products, it's really mostly long journey, because from these ambitious goals till we have early TRLs, as with technology readiness level, where these guys are working on like TRL 0, 1, 2, maybe 3, then we have to pass it to the next level of the demonstrators. And here we have a fantastic tools like the Up Next, where we are doing the various demonstrators, like, for example, for autonomy, where we are testing the various sensors or various methods as well, based on the AI and machine learning, how the aircraft is going to be controlled. Then we have also the tools like the digital proto spaces, which we're just going to open one in India, where the people can develop the new ideas around digital. Of course, we have a very good setup in US, in the West Coast, with A-Cube, we call it, where all digital stuff about AI, cloud, data is happening. And not forgetting very good footprint also in Asia, particularly China, because in China, it's also a lot of things happening. And having privilege working in China and US in the past, I tell you, I think, and we see it already in automotive, that China is shaking the entire automotive industry. Therefore, it's not if the China is going to shake aerospace industry, it's only the question when and how fast. Therefore, being there and working together with these global ecosystems is really important for the leaders like ourselves in this industry.
Absolutely. And looking to the event in Munich now, what are you most looking forward to at ATW Europe?
First of all, I'm really very happy that it's happening in Munich, because the place where I am based today. And it's so close to the heart of all of these disruptive things like hydrogen testing, fuel cells, and so on. Therefore, it's a great place to be. And also Munich is starting to be really startup-driven ecosystem, with a lot of the great initiatives coming from the Technical University of Munich, and there's a venture lab where they have plenty of the startups in the different areas, but also in area of aerospace, which are shaking the big players like ourselves. And therefore, we are opening up and working with them together, because we know that the future is not just what you do in your house, but it's also how you collaborate with this external ecosystem. As I always call it, the global or innovative distributive brain, which you have to access to. Now, what I expect from the Aerospace Tech Week end of March in Munich is that it is not just conference, it's also exhibition. Therefore, we are going to have opportunity meeting this distributed brain, or the incumbents, which we know already players in this industry, but also the new guys coming in and shaking this industry with the great new ideas. Therefore, it's all about collaboration and how to bring people together, align together to achieve the common goals. And the common goal is 2050 net zero from aviation industry. Therefore, there is no question if, the question is how fast we can collaborate in order to reach this goal. And this event is going to give us this opportunity. Therefore, I'm looking forward into it, and to meet all of these great people and to have these fantastic exchanges and plan the next steps.